Fundamentals of electrochemistry. Redox reaction involves transfer of electrons from one species to another. Chemicals are separated. Can monitor redox reaction. An electrons flow through an electric current. Electric current is proportional to rate of reaction. So, some of the basic concepts. Redox reaction is an analytical technique based on the transfer of electrons between analyte and titrant, generally termed as reduction and oxidation reaction. A substance is reduced when it gains electron from another substance. Gain of electrons and net decrease in the charge of species is called as oxidizing agent or oxidant. A substance is oxidized when it loses electrons to another substance. So loss of electrons and net increase in the charge of the species, or it is called as a reducing agent or reductant. Below is the simple example for the oxidizing agent and reducing agent. Now, some of the basics of oxidizing and agent and reducing agent. Oxidizing agent pulls the electron, reducing agent pushes the electron. The push or pull driving force is called as termed as E cell and also called as electromotive force. Unit for this force is called volt, that is equal to 1 joule of work upon coulomb of charge measured with the voltmeter. Now, some of the basics. Oxidation involves loss, reduction involves gain. It can be easily remembered by oil ring. So, loss of electrons oxidation, reduction or gain of electron reduction can be easily remembered by Leo gear. Where the oxidation occurs, where the reduction occurs. Oxidation occurs at anode, where the electrons are produced and ions migrate towards it. That's a negative sign. In cathode, reduction occurs, the electrons are consumed, cation migrates towards it. It has a positive sign. Now, a simple example about electrochemical cell that use oxidation reduction reaction to generate electric current are known as galvanic or voltaic cells. It is made up of two offsets. Oxidation occurs at negative electrode, reduction occurs at positive electrode. Saltbridge acts as a complete the circuit by joining two offsets together. In this simple setup where copper sulfate, copper electrode is dipped, or zinc sulfate, zinc electrode is dipped, it is connected by a salt bridge. The salt bridge maintains the electrical neutrality, it minimizes the polarization, it avoids the liquid junction potential. What happens in this reaction? For example, in anode, zinc gives rise to Zn2 plus 2 electrons. In cathode, copper 2 electrons plus copper 2 plus 2 electrons give rise to copper. The shorthand notation for this cell is zinc and zinc sulfate separated by salt bridge where it is immersed in copper. So anode on the left side, cathode on the right side. Cell potential is nothing but a measure how well a cell reaction can push and pull the electrons throughout the circuit. The electrical energy generated by a spontaneous reaction is proportional to the cell potential. The standard cell potential measured when all the species are in the standard state is given by E naught of cell is equal to E naught of cathode minus E naught of anode. So more negative E naught, more easily electron is added, more easily reduced, better oxidizing agent, more positive E naught, more easily electron is lost, more easily oxidized, and it is a better reducing agent. Whatever we discussed is some of the basics of electrochemistry. For more details on basics about these things, introduction to electrochemistry, you can refer Anil Glaston. Thank you.